Alright, so problem 4 here is about the distribution of M&Ms, and we basically have yellow, red, orange, blue, green, and brown M&Ms. Okay? So basically they go through a series of questions. So the first question is, how many do we expect to get in each in this bag of M&Ms? So if you add up the colors that they got, which I did up here, you get 106. And then they told us the percentage of yellow, red, orange, blue, and green, and then the rest would have to be brown because those have that up to 100%, so there'd be 30% brown. So I multiply 106 by each of those percentages, and that's my expected number from part A. Part B is, what kind of test are we going to do? Well, we're going to test an actual distribution versus an expected distribution. So this is a chi-squared goodness of fit test. Okay, and then C is, what is the null hypothesis? So the null hypothesis, it would be the distribution of colors of M&Ms is as expected. And then the alternative hypothesis would be the distribution of colors of M&Ms is not as expected. Okay, so those are our hypotheses. D is, what are our conditions? Well, the data is counted data. The bag of M&Ms is representative of the distribution of the colors. And then all of our ECFs are right here. So all of our ECFs are at least 5. So we got all 3 of them. All right. And then E, how many degrees of freedom? Well, we have 6 colors, so degrees of freedom equals 6 minus 1, which is 5. And then F, find chi-squared. Well, chi-squared equals observed minus expected quantity squared over expected, right? So what we have is we have yellow, red, orange, blue, green, and brown. And we have the observed. So how many did we get? Well, we got 29, 23. And then we got 12, 14, 8, and 20. And then the expected we would have from up here in our little table up here. So we'd get 21.2, 21.2, 10.6, 10.6, 10.6, and 31.8. So chi-squared, how we're going to calculate it is, I'm going to start with the yellow ones. So the observed was 29 minus the expected squared over the expected. And I'm going to go all the way up to the brown one. So I'm just showing here my calculation. So I'm going to do 20 minus 31.8 quantity squared over 31.8. And I'm going to figure out what that is. Now, I put that data in 2 lists. My observed is in L1 and my expected is in L2. So I'm going to go to stat test. And I'm going to go up to chi-squared goodness of fit test, which is test D. And my observed is in L1, my expected is in L2. I have 5 degrees of freedom. And I'm going to draw that. And we have invalid dimensions, which means we have a stat plot on. So let's try that again. Let's do it one more time. Okay, so there we go. So we're going to copy this onto our paper. So chi-squared is 9.3145. So we're going to copy that down. And we're going to copy this curve down. So it looks like that, and it's shaded over here. And chi-squared equals 9.3145, and big P is 0.0972. And then F is, actually, we already did EF. This is G, so we fail to reject at 0.05 level. So there is no evidence that the distribution of colors is different than expected. And that's our conclusion.